Hey, what's up, Balge 1B? So today we're going to talk about solving quadratics using the zero product property and factoring. You're probably going to want to get a piece of paper, pencil, calculator if you have it. If you don't have a calculator, you can get your Chromebook out, and don't forget you can go to Desmos, has the scientific calculator online. So if you need to, pause the video, get all that stuff, have it together. We're going to go through some examples, have you try some, make sure you're good as best we can, and then we'll move on. So if you have to, pause, go get your stuff, come right back. So what we're going to do today is we're going to talk about solving quadratics by factoring and the zero product properties. Probably the first thing we need to talk about is what is the zero product property. Zero product property is really simple, actually. Zero product property basically says if A times B equals 0, then either A has to equal 0 or B equals 0. It's a pretty simple thing to understand when you think about it. If we're going to multiply some things together and get 0, no matter how many of these we have, whether we have 2 or we have 100 things being multiplied together, if it equals 0, one of those things has to be 0, or more than one. So that's exactly what the zero product property is. Now, how does that help us? Well, we spent a long time taking quadratic equations and factoring them. When we factor a quadratic equation, we're basically turning it into a multiplication problem. So that's what we're going to do today. So hopefully I have all your stuff together. We're going to start going through some examples and see how it goes. So the first one we're going to do is one like this. Now, first thing you're going to notice is that we already have an equation that is equal to 0. If it was not equal to 0, we would first start by getting it set equal to 0. So when we take a look at this, the ones we did before, they had no x term or linear term. There was no bx value. So we could solve that using square roots. This one has that bx term. So we cannot solve this using square roots because we can't isolate the x squared without still having an x. So what we're going to do is we're going to take a look at that and say, okay, it's set equal to 0. Let's see if we can factor that and use our zero product property. Well, of course, since this is just your ax squared and bx term, we can factor this using a GCF. And I'm sure most of you are already looking at it and saying, hey, I can pull a 2x out of there. And you can. So if I factor out a 2x, I'm going to have x plus 4 left, and that is going to equal 0. Now at that point, we have set up our two things that are being multiplied to equal 0. Right here, I'll use a little pink there. Those are my two things. This 2x is being multiplied times this x plus 4, and I'm getting 0. That means we can put in the zero product property. Remember, the zero product property says if two things are being multiplied together and I'm getting 0, that means either that 2x has to equal 0 or the x plus 4 has to equal 0. What that gives us is two very simple equations that we can solve. So if I solve 2x equals 0, well, that's simple. I'm going to divide by 2, and I'm going to wind up with is x equals 0. Or, on the other side, I'm going to subtract 4 from both sides, and I'm going to have x equals negative 4. So my solutions to this is either x has to equal 0 or x has to equal negative 4. And of course, since we're solving an equation, we'll place our solution in brackets. I like to go in ascending order, so I'll put negative 4, 0, and there's my solution set. And what we can do now, if we want, is we could take both of those values, plug those back in, and make sure they work. If you want to try that, go ahead. I'm sure a lot of you probably do not want to, but we can. Let's try another one. This time, we're going to start with an equation. 6x squared equals 42x. Now the first problem when I see that is, hey, that's not set equal to 0. But the nice thing is, we can get it there. So the first thing, I look at this and say, okay, this has an x squared and an x term. I cannot solve it using square roots. So I'm going to have to set it equal to 0 and try to use my zero product property. So the very first thing that I'm going to do is I'm going to subtract that 42x from both sides. Once I do that, I'm going to wind up with 6x squared minus 42x equals 0. At this point, I now have a quadratic set equal to 0. I can factor it and use my zero product property. So looking at 6x squared and 42x, I know that they have a common factor of 6 and x. Set up my parentheses. I'm going to be left with x minus 7, and that equals 0. So now that I have my two things being multiplied together and equaling 0, I can apply my zero product property. So once again, either 6x equals 0 or x minus 7 equals 0. So on this one, real simple, divide both sides by 6, x equals 0. On the other side, also very simple, adding 7 to both sides, x is going to equal 7. So those are my two possible solutions. Putting them in solution set, that was a terrible bracket, I apologize. I get the solution set 0, 7. Both of those will produce a 0 value when plugged in here for x. Now, we can also solve trinomials using the same method. We'll start simple. X squared minus x equals 20. So once again, I have a quadratic. I have an x squared term. I also have an x term. Can't solve it with roots. So what I'm going to do is I'm going to try to factor this after I get it set equal to 0 and use my zero product property. So the first thing that we must do, subtract 20 from both sides. When I do that, I'm going to wind up with x squared minus x minus 20 equals 0. At this point, I have a trinomial set equal to 0. I'm going to try to factor this and use my zero product property. We know that when we factor trinomials, we're going to use our reverse FOIL method. Since this is just an x squared with a coefficient of 1, I can use x and x. Now is where we have to go through our process. We're looking at negative 20. We need two numbers that will multiply up to negative 20. I also need those numbers to add up to this negative 1x here in the middle. So going through the factors of 20, I realize that 5 and 4 are 1 unit apart. If I put in a minus 5 and a positive 4, when they are multiplied, I'm going to get a negative 20. When they are added, I'm going to get a negative 1. Therefore, that will factor into x minus 5, x plus 4. Once again, I have two things being multiplied together to equal 0. I'm going to set each one of those equal to 0. Either that value has to be 0 or this value has to equal 0. Solving both of those very easily, I'm going to have x equals 5, or solving this one, I'm going to have x equals negative 4. Those are the two values of x that when put into that equation will make it work. Putting those in a solution set in ascending order, negative 4, 5. Easy stuff, huh? Let's do another. Let's take x squared minus 18 equals 3x. So this time, once again, I have a trinomial, or I'm going to have a trinomial. I have a quadratic, has an x squared term, has an x term. So I know I'm not going to be able to solve this with roots. So I'm going to bring this 3x over here, get it set equal to 0, and I'm going to try to factor it and solve with the zero product property. So very first thing I'm going to do, subtract that 3x. And when I subtract that, I'm going to go ahead and put it in order and do all that at one step. I'm going to realize that this becomes x squared, then would be the minus 3x, then the minus 18. And on this side, I'm going to have 0. So now that I have it set equal to 0, I can go ahead and factor it, apply my zero product property. Again, setting up my parentheses. Since this is just x squared, coefficient of 1, I know that my lead terms will be x and x. Now I need two numbers. I'm going to multiply up to 18, add up to 3. Keep in mind the 18 is negative. The 3 is also negative. I'm pretty sure most of us going through thinking 18, 1, 19 and 2, but 6 and 3 are 3 units apart. Knowing that they're going to add up to a negative 3, I'm going to make sure that my 6 is negative and my 3 is positive. When they are multiplied, I'm going to get the negative 18. When I do my outer and inner, I'm going to get 3x and negative 6x. That will combine up to my negative 3x. Now that I have that factored and set equal to 0, I can say, all right, zero product property says these two things multiplied to equal to 0, one of them has to be 0. So either x minus 6 equals 0 or x plus 3 has to equal 0. Solving these, add 6, x is going to equal 6. Solving this one, subtract 3, x is going to equal negative 3. So my two solutions are 6 and negative 3. Putting them in ascending order. I'm trying to do a better set bracket there. Negative 3, 6. That's it. Simple enough. Let's step it up a little bit. This one, we're going to have 3x squared, if I can see that, minus 7x is going to equal x squared plus 4. Ooh, that's got a lot of stuff in it. No big deal. So the first thing to do is go, all right, I do have an x squared. I have two x squareds, actually, and I have an x. So obviously I can't use roots to solve this. So I'm going to get it set equal to 0, try to factor it, apply my zero product property. So keeping in mind that I have a 3x squared over here, and that's larger than x squared, I'm going to bring this stuff over here. Plus, we're used to seeing what we like on the left-hand side, 0 on the right. So I'm going to get rid of the x squared and the 4 from there, make that 0. I'm going to do that in one step. I'm going to subtract the x squared and subtract the 4, subtract the x squared and subtract the 4. Now, make sure you get your like terms together and in order. 3x squared minus x squared, and of course this is 1x squared, is going to give me 2x squared. This 7x has nothing to combine with it, so we're going to bring him down. This minus 4, nothing to combine with him either. We bring him down. And of course over here, they're all inverse operations, eliminates everything over there, and we have 0. So once again, I have a trinomial set equal to 0. I'm going to factor this and apply my zero product property. The only difference is when I factor this guy, since my lead coefficient of my x squared is a 2, I'm going to have to use a 2x and an x. So of course, when I choose my values for over here, I've got to keep in mind that whatever I put in here will be multiplied times to 2 and will affect my middle term. So my last term is a 4. So I know that I can use the factors of 4, 4 and 1, 2 and 2. However, since I'm trying to get a 7 in the middle, I'm going to realize if I try to use 2 and 2, there's no way I'm going to wind up with a 7. However, if I use a 4 and 1, keeping in mind whatever gets in here gets multiplied times the 2, I can create the 7. If I put a 4 here and I multiply there, I'm going to wind up with an 8x. If I put my 1 here, I'm going to wind up with a 1. Since this guy's negative, one of these has to be negative, one has to be positive. But since the negative 7 is negative, I'm going to make sure that I put my negative with the 4 so that when I multiply these, I get to negative 8x. I'm going to put the positive to 1, so I get a positive 1x. And when they're combined, I'll get the negative 7 in the middle. So now, two things multiplied together to equal 0. I'm going to go ahead and set them both equal to 0. 2x plus 1 equals 0. Or x minus 4 has to equal 0. This one's going to take 2 steps this time. I'm going to subtract 1. I'm going to wind up with 2x equals negative 1. Divide both sides by 2. I'm going to wind up with x equals negative 1/2. Whoosh, just had enough room there. Over here, add 4 to both sides. And that's it. Single step. X is going to equal 4. So again, putting those in a solution and in ascending order. I'm going to squeeze them in down here. I've got negative 1/2 and 4 as my solutions. Easy peasy. Okay. Let's move on. Now, the next one we're going to do, we're going to actually do 2 different ways. And this will answer some questions we talked about a while back now. So we're going to take 4x squared plus 8x minus 60 equals 0. Now, don't be worried about the two ways. You pick the way that makes the best sense to you and use it. I have a feeling the majority of you are going to look at that and go, okay, anytime we were factoring, I told you time and time again, if you can take a GCF out, do it. So when I take a look at 4x squared, 8x, and 60, I can take a GCF out of there. I can take a 4 out of all three of those terms. So why wouldn't I? I'm going to take a 4 out of there, set up my parentheses, have it equal 0. Now this is where it gets real nice. When I pull a 4 out of there, I'm going to have x squared plus 2x minus 15. Now, why is that real nice? Well, in this case, since I have an equation and I'm not just factoring, at this point, what I could do is I can divide this by 4 and divide this by 4. The nice thing is that eliminates the 4, and over here, you still just have 0. So your trinomial got a lot easier. So now, I can factor this. Lead terms, x and x. Two numbers that multiply up to 15, add up to 2. Keep in mind that 15 is negative, 2 is positive. Clearly, I think most of our brains go straight to 5 and 3. They're 2 units apart. I know that I'm going to use 5 and 3 to get to 15. 1's got to be negative. Since the 2 is positive, this guy's going to be positive. That guy's going to be negative. Now that I have my two things multiplied to equal 0, I'm going to set each one equal to 0 using my 0 product property. At this point, solving those, very simple. Now the x equals negative 5. Over here, and x equals 3. Now I'm going to put my solution set off to the side here. My solution set would tell me that I've got negative 5 and 3 as solutions. The reason I'm going to leave that there is we're going to do this a whole nother way. I have a feeling, like I said before, I think most of you will prefer this way because it takes your trinomial from not too large numbers, but more difficult numbers to factor to a simpler thing. So if you can take a GCF out, it only makes your life easier. So if you can, I highly recommend you do. Now, I know when we were factoring, there were several people that pointed out, hey, I can factor this without pulling out that GCF. Well, yeah, you can. So if I take a look at this and I say, I'm going to go straight to factoring. Now, the trick here is going to be, since I have a lead term here of 4, I can use a 2x and a 2x or a 4 and a 1. It's up to you. Give them a try. One may work, one may not. They both may work. So what I'm going to do is I'm going to go straight to 4 and 1. And again, if you were good with the other method and you do not like this, it's fine. Just watch, then ignore it. You can always pull out the GCF. So if I look at this and say, okay, I need factors here. That's going to give me what I want. What am I going to use? So I start going through all my stuff here with my 60s and I say, okay, what are the factors of 60 that will make this work? So there's a lot to consider. I'm going to go immediately to 12 and 5. The reason I'm going immediately to 12 and 5 is I know whatever gets multiplied or gets put in here gets multiplied times 4. I'm trying to get 8 units apart. I know that if I take the 5 times the 4, I'm going to get a 20. And then the 20 and the 12, they're 8 units apart. So I'm going to go ahead and say, all right, cool. I'm going to put a 5 in here. I'm going to put the 12 in here. Now, since I want the 60 to be negative, one of them has to be negative, but I want the 8 to be positive. So that tells me that I'm going to make the 5 positive because when that multiplies, I'm going to get a 20. I'm going to make the 12 negative, so when that multiplies, I get a negative 12. That gives me the 8 in the middle. Again, you can do this a couple different ways. If you like the way before, that's fine. Just watch and listen. So when I solve this, I say, okay, 0 product property, 2 things multiplied together. That means 4x minus 12 equals 0, or x plus 5 equals 0. Solving both of these, add 12. I got 4x equals 12. Divide by 4, divide by 4. X is going to equal 3. Over here, subtract 5 from both sides. I'm going to have x equals 5. I'm sorry, x equals negative 5. If you notice, I left the solution over here to show you. If you don't pull out a GCF and you go straight to the factorization, you will still get the same result. Pulling out the GCF makes the factorization easier, whichever way you prefer. I think we had the discussion a couple times when we were doing factoring. So this is the point I told you we would get here, that at some point, it doesn't matter if you pull out the GCF, it just makes things easier. So hopefully you're okay with that. Here's what I'm going to do. I'm going to put 3 examples on the board. I want you to try to solve them. Then I'm going to put the solutions up, and we're going to see if they match. So here are your 3 choices. We've got 7x squared plus 21x equals 0. Number 2, I've got x squared equals 3x plus 28. And my last one, 4x squared minus 15x equals x squared minus 12. So what I'd like you to do right now, pause the video, write those down, solve those on your own, and then restart the video and check out the solutions. Pause it. Try it. I'm waiting because I know some of you aren't going to pause it. Okay, ladies and gentlemen. I'll put that one back up in a second. Just want to make sure I have some room. So, we'll start with this first one. Take a look at that. I have no C term. It's not a trinomial. The only thing I'm going to do is I'm going to factor out a GCF. So I'm going to pull out my 7x. I'm going to be left with x plus 3. That's going to equal 0. The 2 things being multiplied here are 7x and x plus 3. I'm going to set the 7x equal to 0, or x plus 3 equals 0. Solving those both, divide by 7, x equals 0. Or over here, subtracting 3, x equals negative 3. So my solution set is negative 3, 0. Pause if you need to look at that. The other one, the first thing that I would notice is it's not set equal to 0. Since I like to keep everything on my left and the coefficient of x squared positive, I'm going to bring the 3x and the 28 over to this side. That's going to give me x squared minus 3x minus 28. And over here, that all goes away. So at this point, trinomial, lead coefficient of just 1 in front of that x squared. X and x. 2 numbers multiply up to 28, get you a 3 in the middle. I'm looking at 7 and 4. Keeping in mind it's negative, therefore one of those is going to be negative. One's going to be positive. Since my middle term's negative 3, I'm going to make that minus 7 plus 4. There's my 2 things. X minus 7 equals 0, or x plus 4 equals 0. Adding 7, x is going to equal 7. Over here, subtracting 4, x equals negative 4. My solution set is negative 4, 7. Pause the video if you need to. See if you agree. Now, the last one. Looks scary, didn't it? It looks real scary. We had 4x squared minus 15x equals x squared minus 12. So again, first thing that I'm going to do is look at that and say, you know what? I need that to equal 0. I'm going to bring these things over here. Subtracting x squared, adding 12. Subtracting x squared, adding 12. So 4x squared minus x squared is going to give me 3x squared. The minus 15x has nothing to combine with it. And the plus 12, nothing to combine with that. On the other side of the equal sign, x squareds are going away, 12s are going away. That equals 0. Now that I've said it equals 0, factor, 0 product property. Ooh, looking at that, 3, 15, 12, I can take out a GCF. I'm going to do that because I think most of you would prefer to do that. You're going to have an x squared minus 5x plus 4 left behind. Now at this point, I can divide both sides by 3. All that's going to do is make that 3 go away, and that 0 is going to stay put. So I'm just going to cross that out, mostly for room. Setting up my parentheses, x and x. I need two numbers that multiply up to 4, combine to give me a 5. Well, clearly, 4 and 1 are going to be the only way that happens. And of course, if I want to get a positive here, I need to make sure that that 4 and 1 are both negative, because that will give me the positive that I need there for my last term. And when combined, negative 4x, negative 1x will give me the negative 4, or negative 5 in the middle. Setting each one of these equal to 0 using my 0 product property. Adding 4, I have x equals 4. Adding 1, I have x equals 1. My solution set, sorry, I'm out of room, 1, 4. Guys, if it seems simple, it pretty much is. Hopefully that you followed along with that. If you have any questions, shoot me an email. We'll help you with that. On Canvas, there is the next CUDA worksheet, solving by factoring. I'd like to give that a try. The first 2 pages, you actually have a hard copy of that as well. So the first 2 pages are just the problems. The next 2 pages, and it's all one document, shows the solutions. Try one, check the solution, or do them all and then check them all, whatever you want. Questions, email me. Remember, Fridays, we're going to set up so that I just go over any questions you have. You can just tell me, hey, solving by factoring, had trouble with number 3 and number 7. Okay, and we'll set up a video where we show all those, and you can just, of course, skip through and go to what you need. Hope that helped. Hope it made sense. Talk to you guys later.